All right, so when we're solving exponential equations, again, the difficulty is that the x is in the exponent position, and we cannot just pull it out and say, you know what, let it 4x equal x plus 1 if the bases of these powers are different. So in this method of solving exponential equations, remember what we have to do first is take a look at the bases of each power and ask yourself, can we write these with this, as powers with the same base? And of course you can with 9 and 27. So the solving process looks something like this. That 9 right here, we're going to turn into 3 squared. In doing that, we still have to keep the 4x as the exponent, right? And over here, 27 can also be written as a power of 3. And that is 3 to the power of what?
3.
Right, it's 3 cubed, or 3 to the power of 3. And so we still leave this exponent here. Now, why is this helpful? Well, as we've already learned, that if we have an equation and we have powers, one power on this side and one power on this side, and they have the exact same base, then the exponents are equal. And even if we have an unknown part of those two exponents, then we can solve for that. So this is what we're going to do. We need to expand here yet. So 3 squared to the power of 4x is going to be 3 to the power of what? Shout it out. 8x. Good. We multiply these. Okay. Equals 3 to the power of, and again, this is 3. Yeah. You have to distribute that. So this is 3 to the power of 3x minus 3. Now that we have this situation, we can absolutely let the exponents equal each other because everything else is held equal here. And now we can bring this out of the exponent position and just let 8x equals 3x minus 3. And use our powers of algebraic manipulation. Ooh, that sounds pretty dastardly, doesn't it? Powers of algebraic manipulation. Boy. I would not be a very good husband if I brought that into my marriage. Use my powers. Anyways. So this is not going to work out too evenly here, right? It's not going to be an integer. It's going to be a fraction, but I think that's going to be okay. Right? Am I doing everything right here? Minus 3. So then x is going to be equal to negative 3/5. We good with that? Okay. Now, do we have this right? Because it's like, well, I got a fraction, so it's probably a wrong answer. I know how you guys think. So let's check. All right. So the check over here, we're going to do a little bit of a check. So what we're going to do is we're going to put that, what was it, negative 3/5? We're going to put that in the original equation, negative 3 over 5, in for x. Now, I know what you're thinking. You can just plug this into your calculator. Yes, you can put 9 to the power of, make sure you use big fat brackets there, 4 times, and then another brackets, whatever. Yes, you can plug this into your calculator and check. I'm totally fine with that. If you didn't have a calculator or you want to work on your, your fraction, your skills here, because you should try and hone these skills a little bit, what you're going to want to do is just expand this out and see what we get here. So 9 to the power of, when I have a power to a power, you multiply, so it's going to be negative 12 over 5, right? Over here is going to be 27 to the power of. Now, if I have a fraction and I minus a whole number, I have to get a common denominator, right? So 1 is actually 5 over 5, isn't it? So what's negative 3 minus 5? Is negative 8 over 5. Okay? Does that help us? Not really sure. But again, if we change these into the same bases, we can try and get this to look the same. So 3 squared, to the power of this right here, and this is 3 cubed to the power of this right here. And so this is going to be 3 to the power of negative 24 over 5, and this is going to be 3 to the power of negative 24 over 5. And that is good enough for you to say, yeah, I think my x value was correct because the left side equals the right side. Okay? So that's a trickier one with a fractional exponent and solving exponential equations using the same base method there. All right, so another way you could solve this equation algebraically is by using logarithms, but we're going to save that for next chapter. The logarithm chapter, and I'll explain how that happens as well, because that's, you don't need powers of the same base using logarithms to solve exponential equations. So that's a great method. That's where we're going with this. But for this section, it's solving graphically using same base method, and it's solving algebraically with the same base and solving graphically. So you've done this before in this course. Let's just go over what we would do. If we're going to solve graphically, what we'd want to do is we'd want to graph. Okay, there's two different ways you could actually do this. You want to graph y equals this function right here, and then separately y equals this function. If you do that, the solution to this equation will be where those graphs intersect, right? So that's one way. I think that's probably the easiest. The other way you could do it is to move everything from one side, move it over to the other side, graph that one equation, and then find the zeros. So that is where that new equation hits the x-axis. So you may remember this from before. I'm not sure. I'll do the first method here. So again, let's type this in. 9, oops, not 99, to the power of, and good idea to use brackets, whenever you can, overuse your brackets. 9 to the power of 4x. Now, let me just look at something. Okay, your calculator may be in degrees. I think you should probably go to radians here. Not going to make that much of a difference, but just so we're all on the same page here, because we use this calculator for another class. So 9 to the power of 4x, and then 27 to the power of, make sure you use your brackets, x minus 1. Remember, this is a minus, this is a negative. Don't interchange the two. Your calculator won't be happy. All right, so if we graph those two and you hit graph, we have to think about where these graphs are going to be. Look at this. It's pretty tight there. I have one of those graphs there. Here's the other one. So right now, it's not really clear at all to see where the intersection point is it? So what we need to do is zoom in. You can change your window manually, or you can use this zoom in function. So zoom number 2, and then it's at the origin here. You just hit enter. That's where you want the center of your screen still to be, and it'll zoom in for you. It just zooms in. Now this actually might work out pretty good. Let's see where that other one comes about. Okay, still pretty tough to see there, and that's because it looks like the graphs might intersect somewhere over here. So I'm going to do one more thing just to zoom in, just to make sure. Let's go to the window setting, and then the y minimum and maximum. Let's just adjust those. Okay, let's go to -1 and +1 and see what that does. See if we can see this any clearer. So there's our first graph, and here's our second graph. Okay. Interesting. It looks like they're going to touch down here, but again, we still can't quite see it. All right, we don't need to see that very plainly with our naked eye. Instead, what we're going to do is we're going to now search for the intersection point. So go second function, trace. You come to the calculate menu, and you want to choose number 5. That's intersect. Okay, so again, that's second function, trace, number 5. And then it'll ask you, and it'll show you up in the corner here, is this the first curve you want me to consider? Well, we only have 2 plugged in there, so it should just pop back and forth. Second curve, yes. And then guess, okay? So you just hit enter once more for the guess, and let's see what comes up here. Oh, look at this. The x value, even though it's difficult to see this y value, because look, it's so small, but the x value is -0.6, okay? So graphically, and really, what you would want to do for graphically is you'd probably want to just sketch that graph so that you can, you'd want, this would be your work, okay? Because you're doing most of this on your calculator, but just a rough sketch here, okay? And then, it's pretty tight to see, but rough sketch, and this right here would be -0.6. So you just say x, which is the intersection point here, is -0.6. And if you recall, we just did the algebraic method, and what did we come up with when we did that? X would equal -3/5, which is the same as -0.6. Your calculator will give you a decimal answer. You can certainly change that into a fraction if you're asked to. Okay, so that's the graphic method that way. And again, I'd like to show you just real quickly the second method, which is making one equation of the two and finding the roots. So again, really, I'm going to leave this actually, negative 0.6, because if we do it this way, we should still get the same answer. So watch this. 0 equals 27 to the x minus 1 minus this. And if I graph y equals as a single function and find the 0, that's your method 2 of solving graphically. So let's just do that. Let's go back to the y equals. And instead of plotting 2, I'm just going to go down here and do this. 27 to the power of x minus 1 minus 9 to the power of 4x. Okay, again, you should overuse your brackets, so I'm going to overuse my brackets there. Don't know if I need to actually, but I'm going to try that. So let's see what happens. Okay, so we have a very different looking graph. But again, what we're trying to find now is the 0. So let's do second function trace and find the 0. That is the X-intercept. So if we do that, you're going to have to do the boundaries here now. So left boundary, let's try and get as far over to the left as we can. It's really tight by that line, isn't it? Okay, but we're going to say that's a left boundary, and then a right boundary is going to be, now you should watch these values here. They flip from a positive now to a negative. You see that? So they were positive before, and now they're negative. So this is to the right of the intercept. And then, of course, we hit enter, and it should be calculating for us an intercept somewhere around here. And look at that, negative 0.6. This number, remember the calculator sometimes says 0, but sometimes it says an extremely small number, because it's trying to pick one of a near infinite number of little points there. Okay, so just treat that as 0. So there's method number 2 for graphic, and you get the same answer all around. Okay, so here's what the graph sort of would look like, and then it comes down like that. All right, any questions? You got that? Okay, so there's some notes. Take a moment to look through those notes. Okay, and 7.3 here, here's your assignments, 7.3. You can do 1 to 7, and you can do A and B for those, and then number 8. So that will be your assignment from 7.3. 1 to 7 and 8. And of course you can do more than just the A and B if you wish. And here's the textbook questions if you need some. If you forget your textbook, you can check them out here.